do some network design. The first step in any design is requirements. You'd be surprised how many people don't do this step, but it can be very quick. So I threw together 5 requirements here just real quickly, and we'll go through them real quick. And first, how many station IDs? Well, let's say this is a small office, maybe 20 people. Let's call it an even 100. Okay? Any subnets for any departments? No, our company is not big enough to have any departments. I do want a restricted subnet for visitors, so we're going to say yes here. How big? Say 20 addresses. We probably won't have that many visitors at once. How many DHCP IPs? And DHCP stands for Dynamic Host Control Protocol. And that's what, when you turn your PC on, it gets an IP address. We're going to say we want all 100 plus the 20 for the visitors. So we're going to say 100 plus 20 for the visitors, because we want all these on DHCP. And how many static IPs? Well, let's say there's 20 people in this company. Let's say they're sharing a big printer and maybe a fax machine and some other miscellaneous equipment. Let's just say we need 10 to 15 IPs that are static, printers, servers, that sort of thing, and we can adjust this as we go along. First, we need to pick a private IP address space. Here are the private IP address spaces available to us. These should not route on the public network and are safe for us to use. I say should not route because I ran into a service provider that actually routed on the 10 dot network, even though they shouldn't. So from our requirements, I think a Class C network should suit our needs. Class C networks are largely used in homes and small offices, or peeled off larger Class A networks or Class B networks for departments to use. So we're going to choose our Class C network, and I'm going to use 192.168.10.x as our Class C network. So this will be the network ID and the station IDs. Okay, you're probably asking, well, why 10? Why not just 1? Start from 1. Well, the problem is every new piece of equipment of hardware comes with 192.168.1.x as the default IP address. And yeah, that's great, but that's also the problem. So say for example you have your brand new nice clean network all set up, everything's running, you have a coworker runs down to Fry's or local electronics store, buys an Ethernet switch for his or her desktop, and they want to plug in some other little gadgets and devices, and so he or she plugs in this brand new Ethernet switch, and it has the same default IP address as say for instance your gateway router or your DNS server or some other business critical server. And you can watch as your network comes crashing down around you, and you spend the next several hours tracking down the culprit piece of equipment and the dodo that plugged it into your new pristine network. You might also be wondering why I picked 192 network instead of a 172 or the 10 network. Well, generally, and this isn't written in stone, but generally the 10 network are for Class A networks. The 172 network are going to be your Class B networks, and your 192 networks are your Class C networks. Okay, so when laying out a fairly simple network, An Excel spreadsheet is really all you need. More complicated networks with multiple routers, switches, and subnets require a top-level drawing with multiple Excel spreadsheets and maybe even multiple drawings. However, today, besides not only do I want to do the Excel spreadsheet, but I also want to do a network drawing just to kind of show the thought process I use when putting together a network from the ground up. So to get started, I usually start from the bottom, which is a good place to start. And that would be, okay, what network equipment do I need? What are my servers? The stuff that's going to have static IP address and that sort of thing. So I know in our little sample network that we're going to need, we're going to have 3 servers. And I'm just basing this on what I have in my office. So so here's the 3 servers. There's 2 Linux servers and a Windows server. And I'm just copying and pasting this from another drawing. And these are just drawn in Word. These boxes, they don't have to be fancy. It's just so you know what they are. Okay, so we've got our 3 servers. We know these servers are going to need an Ethernet switch. So let's pop in an Ethernet switch here. And 100 DHCP addresses, if I remember correctly. And that's for some wireless devices. So let's see here. Okay, this is my version of a laptop. And I'm just going to put that in here, and since we're going to have 100 of these, I'm just going to make a copy of this and say this is laptop for employee 1, do 100. And to kind of show that there's a that's a continuum, is I'm going to put an ellipse in here, and this just kind of shows, okay, there's 100 of these laptops, and they're going to be wireless, and they don't have to be laptops. Obviously, they can be any tablet, iPad, phone. And it's just like I said, it's just a placeholder just to show that there's going to be 100 wireless devices, and since they're going to be wireless, we're going to need a wireless access point. So we need one of those guys in here. And we'll put him right here. And our wireless access point is going to need an antenna. So we're going to stick him right here. And so this is going to be the this is going to be the access point for the internal wireless network. And it's traditional to draw, well, it's supposed to be like a lightning bolt. I know that doesn't look too good, but you kind of get the idea. So that's, they're wireless. Okay, so what else do we need in our network? We need, we've got a printer. So let's pop a printer in here, and some SIP phones. So let's put some SIP phones in here. Now in my office we use video phones. So, but for this example, and to make these just regular SIP phones, you can just, if you ungroup these, and you can just chop the top off them, the video, and then now you've got a SIP phone. But in my network, there's going to be SIP phones, video phones that are SIP, and they are also, we're going to just kind of leave them. We don't know how many of them we're going to have in our example network here, so I'm just going to put an ellipse in between them as well. Okay, so all this stuff is going to be DHCP, so we can start labeling some of this equipment here. So we know these are going to be DHCP as well, so we'll pop that guy down in there. And another thing that we're going to need in our network here is most of the time SIP phones require a power over Ethernet switch to be powered. They don't have to be, but it is very common. So we're going to make this switch a PoE switch for power over Ethernet. All right, and okay, you can wire in. Oh, one last thing we need. We're missing our layer 3 device, our router. So let's pop that guy in here. All right, and you see I'm kind of doing a hierarchy. It doesn't. This is just the way I draw it. Like for example, I usually try to put the provider edge or the IP cloud at the very top. So why? Because I don't know, clouds floating there, I guess. It doesn't have to be this way is what I'm saying. It's just the way I'm used to drawing them. So I'm going to start wiring some of this stuff together. So we got the provider edge. Okay, so we got a router, and we need to start connecting some of this stuff up. You can do straight lines like this, and that's okay. I usually prefer drawing at right angles. To me, it just looks better. It looks more like a schematic, I guess. Probably not good to mix and match, but since it's our own personal drawing, and usually what I do with these drawings too is I'll hang them up on my cube wall or something, and if I need to, I'll print it out, I'll hang it up on my cube wall, and if I need to make a change to something, I can just exit out and add whatever I need to add in there, if it's another piece of equipment or taking a piece of equipment out. And then after the drawing on the wall gets so marked up you can't hardly read it, then you go into your electronic version of it and then clean it all up, and then hang the new one back in there and just keep it going. And that's one of the nice things about having an electronic version of this is it's real easy to modify. Okay, so I'm just connecting everything up, and what's another nice thing about a drawing is immediately we know that this Ethernet switch here, which we can name and give an IP address to, which we'll do in a minute, it's going to have our printer and our access point and all our servers, and this Ethernet switch over here we know is just going to have our phone system. So, and that's good to know when you're troubleshooting something. You can take a look at your drawing and real quickly determine exactly what what switch is connected to what, and that can be a little bit more difficult with the Excel spreadsheet. So I'm going to go ahead and save this, and we're going to look at the Excel spreadsheet next. Okay, so what I've done here is I have fired up an Excel spreadsheet. This is where we're going to start laying out our IP address design. So one of the things I wanted to note, I also put the requirements in the spreadsheet right here so we could look at them while we're assigning IP addresses. And I just copied I had to fire up the video to see what the requirements were. I'd forgotten them. So one thing I wanted to point out before we got too far off the drawing was if you notice, there's two wires running into the router, and and that is, I don't want to say it's uncommon, but normally you have one port out of a router per network. So in other words, since our network is, and I'll just 192.168.1.0 with a subnet mask of 255. Oop, can't see that. 255.255.0. So that's our base network, our Class C network, and you can't, in routers, will not let you assign this network to two different ports. And the reason why is they just don't, the router doesn't know. It won't allow overlapping networks like that. The layer 3 part of it won't. However, most routers will allow you to group ports. It's almost like a bridge, except they don't call it bridging. It's more of a routing group. And we can get into that later. I might just go ahead, just for simplicity, and say that there's another, we'll call it another Ethernet switch right here. And this might be a little more clear. So let's say there's an Ethernet switch right here. It's got one port coming out of the router, going into this Ethernet switch, and then this Ethernet switch is splitting between the other two Ethernet switches. And this is actually fairly common setup. Like I said, a lot of routers nowadays, a lot of routers are layer 3 devices, do layer 2, and a lot of layer 2 devices like Ethernet switches do layer 3 routing. So, but I didn't want to really get into that, and I'm also going to name this gateway, because it is our gateway to the provider edge. Okay, I just wanted to clear that up a little bit. So now, this network is on this one port right here, and that makes more, it is visually more easy to see, let's just say. So okay, so back to our Excel spreadsheet right here. Oh, another thing I wanted to point out too, I noticed in the requirements is the first requirement was we're trying to figure out how big our network needed to be, and I said 100 station IDs. And then I said, then we're going to have 120 DHCP IPs and 15 static, and well, that's obviously over 100. So I think what we're just going to say is Class C, if you want, which is approximately 256 IP addresses. Okay, so the way I usually start laying out the IP addresses, I just type in 192.168.1. Oops, it was .10.0. I think I mislabeled this one too, using 10. Okay, and so I'm going to just do that 4 times. 2.168.10.1, 192.168.10.2, and 192.168.10.3. And then I'm going to put an underline under this. And if you remember from our subnet mask, I just say allowed subnet masks, or allowed subnets, I should say. The sequence goes, it's 1, 2, 4, 8, 16, 16, 32, 64, 128, and 256. Now we just keep this in the back of your mind. You don't have to write this out, but this is just so you keep this in your back of your mind. And so usually 4 IP addresses is the smallest subnet you're going to want to use, unless you're using the single IP address or the 2 IP address, which is not normally used in this situation, and we'll see more of this later where those are used. So so I just drew out 4 IP addresses. I'm going to highlight all 4, and then I'm going to use this copy and paste function in Excel, and I'm just going to drag this all the way down until I get to 256 IP addresses. And you can see it copied the lines and grouped everything in groups of 4. And then your top one right here is at 255, and there is 256 IPs, and the top one should be 255. So, and that is not a usable one because this is your broadcast address. And so we're just going to label him, and I'm just going to mark him in red. Yeah, so that definitely can't be used. All right, and let's see here. What's another one? Okay, this one right here cannot be used either. All right, so, and this one right here is your wire address. I just call it wire. And so in your Class C, well, for any network, you always have a wire address and a broadcast address, and that's just the way IP works. And that's where I was saying, when you get to this subnet right here where there's 2 IP addresses or there's 1 IP address, that doesn't apply. So that's why I was saying they're kind of a special case. So, we've got our wire and our broadcast laid out, and normally in a network layout is the first IP addresses is going to be are going to be your network equipment, and it is very standard to make the default gateway or the router, make him a .1. So I'm just going to say .1. I'm going to put him right next to that wire. There. Okay, so he's .1. And so we've got some Ethernet switches here that I'm going to call this Ethernet switch 1. I'm going to call this Ethernet switch 2 and Ethernet switch 3. So we're just going to start adding these guys in here. So we got E switch 1, and then 2 and 3. Okay, and so now we can start giving these guys IP addresses. And these are for managed switches. You don't have to do this for dumb switches. Dumb switches being ones that you can't SSH or has any kind of interface to provision them. I think I made a mistake there. This guy is .2. This guy is .3. It's kind of confusing, isn't it? Switch 2 is really 3. And you can IP these any way you want. I'm just showing you the way I like to do it. Okay. So now we've got IP addresses for all our Ethernet switches, and so I'm going to go back to the spreadsheet right here, and I'm going to think to myself, well, you know, we might have some future expansion, right? Or we might need to do something else. So what I'm going to do is right now we're using you know, 5 basically IP addresses. So I don't know. I'm going to extend that out to maybe to here. So we'll, I don't know, 15. That should give us plenty of room for expansion. So what I'm going to do is I'm just going to And if you see, I kind of looked over here to say, okay, 16. You know, I'm just gonna kind of lay this out where these guys right here are all reserved for network stuff, and I kind of do this in the back of my head. Is it required? Could I just make it to right here or right here? Yeah, you can. It would be. It's just not something I do, and it's because if I ever want to come back and subnet this thing out, then I have to start rearranging everything, and I just don't want to do that. So I'm just gonna reserve all this stuff right here for network equipment. So now we look at our drawing over here and say, okay, well we need some static IP addresses for these guys, and the reason why you put static IP addresses for servers normally is so it makes it easier for you to get into, and unless you have your own DNS server inside there, and it just dynamic IP addresses can just be a real pain for servers. So and I know there's probably going to be a lot of people that argue with me about that, but for me, printers, any kind of network equipment or servers, something that isn't really direct used by a user, and doesn't need dynamic IP addresses, is not ever going to move, I put static IPs on. So we're just going to do that. So we're going to come back over our spreadsheet here, and we're going to say Linux 1 server, Linux 2 server, and Win 8 server. Okay, so now these guys have IP addresses, so I'm just going to copy one of these guys. And you see what I'm doing? I'm just this is how you lay it out. It's really quite simple. So we got that. So this guy is going to be 17. This guy is going to be 18. All right. Oh, and I just noticed this. So here's our WAP, our wireless access point, and I didn't give him. I would consider that a piece of network equipment. So he actually needs to be in this category up here. So we're just going to put our WAP. I'll give him a name. I guess I could call him WAP 1. Maybe that would be better. Alright, just call him WAP 1. We don't care what kind of WAP it is. Alright. And so he is .5. So we'll just give him an IP address. And then, yeah, we've got our printer here. I kind of want the printer easier to remember, so I'm gonna move him to .20 here, and we'll just call him printer 1. And is that necessary? No, but to me, it's just easier to remember if it's a .20 or a .30 or something, because a lot of times you'll need that when you're setting up your PC. The newer PCs now, with all discovery protocols running, and it's not really that necessary anymore. But in the olden days, when you had to map printers to IP addresses, it really paid off to have something that you could remember, especially if you're setting up if you're an IT guy setting up multiple people on printers. Okay. And so these guys right here, these SIP phones are going to be, we'll just call them, they're DHCP and they're SIP. Probably goes without saying it there, since they're sitting on a Ethernet switch, but just to clarify. So I think we've got all the static IPs that we're going to use, that we have in our network laid out or assigned. So so now I'm going to come back, I'm going to look at this. So one of the things we need is we need, I said 100 DHCP, where's our requirements at? Yeah, so I said 100 DHCP IPs plus 20, and I think that was for this subnet here for the restricted visitor. So, and that's just kind of confusing, so I'm going to just take that off. And I said 15 static IPs. Well, yeah, that's okay. Why don't we just do 16? That sounds like a reasonable number. So I'm just going to come in here and 4, 8, 12, 16. And we're just going to, let's call these, they're static. I don't know, what's a good color for static? Blue? That sounds good. Done this requirement. This is done. This is done. We haven't done this yet. The DHCP we haven't done, but we have done this. So, so green, done, not done, done, and done. Okay, so yeah, so looking back at our drawing, okay, so I need DHCP IPs for these phones. We don't really know how many phones we're going to have, and I said 100 right here for laptops, so we need to come back to our requirements and rethink this. So we've got maybe 150, or here we go, how about 128? You know, looking at our allowed subnets, that gives I mean, there's probably never going to be 100. I mean, we could probably do 64 and be okay, but with all the, you have to remember, you know, one person might use, you know, 3 or 4 IP addresses. They might have, you know, an IP address for their phone, IP address for their tablet, an IP address for their PC. What else they got sitting on their desk? They might have their own printer that might need an IP address. There's, you know, if you've got 20 employees, they're going to use up 80 IP addresses probably. So I don't want to make this any smaller. We're just going to expand that. We're going to make it 128. That'll give us that should give us plenty for our small office here. And so here's 128. So my first thought is to just peel off this right here. And I know it's not exactly 128 because we've got the broadcast guy up here, but it gives us 127. That's good enough. Okay, and so I'm kind of thinking, okay, well, and what does that give us for future expansion? Well, it gives us quite a bit actually. Let's go ahead and mark these real quick. I'm just gonna, let's see, they're DHCP. We'll call them orange. Okay, and just say DHCP. And that is for the phones and the wireless devices. So and by the way, looking at our network right here, you might be asking yourself, well, where is the DHCP coming from? And it's actually going to be coming from the router here. So I'm going to adjust my network again. I'm going to make this guy a little bigger and say, yeah, so he's going to be the DHCP and the DNS server as well. And my cloud's getting a little too close to the top right there, so I'm going to go ahead and just move him off to the side. Yeah, so he's going to be our DHCP server and DNS server as well as our gateway router. So, and that should be okay. We'll assign just one DHCP address space inside our router, and he'll be able to boot all these guys all the wireless devices and all the SIP phones from that one address space. So that's great. So now we have all this other space for expansion. Okay, so this is pretty nice layout. If you know that you're never going to need to subnet this, and the reason why, so it's nice because if I need to extend my DHCP range, I can't go up. I'm at the very top, but I can go down. So I can, or down being up. You get the idea. So I could assign 50, 60 more IP addresses pretty easily, just by a click of a button, and then just go in the router and make the changes to the DHCP address space, and it works out very nicely. And it's always easier to expand DHCP than change DHCP, because if you've got 100 IP addresses assigned and all of a sudden you say, well, I want to, let's say you've got, let's start up here. Let's say all these IP addresses are, all these IP addresses are assigned, but you need more address space for something else. And you say, okay, well, I'm just going to unassign all these IP addresses and give back to the stockpile, and then I can extend maybe my static IPs or something a lot further, or give it a lot bigger space. The problem is that when you start taking IP addresses away from DHCP, well, if they're already assigned, then you're going to be stuck with duplicate IPs, or you're going to have to reboot every device in your office to release that IP address and get a new one from your DHCP server. It can be a real mess. So it's always better to go bigger with DHCP and not try to move it or trim it. And so that's why I kind of put it at the very top right here. I'm like, okay, well, we're going to start at the very top, and then we can always add more if we want to. And static IPs are kind of the same thing. You don't want to have to go on a bunch of equipment and change it, but it's always easier to make it bigger, the space bigger, than it is to make it smaller. Okay, now that we've laid out our Class C a bit, starting to look like a real network. Let's look at our requirements. Class C space, 0 subnets. We still haven't done our visitor network, but we did get our IP addresses squared away. So and now we'll look at the visitor subnet. And I put subnet in there kind of mistakenly. It is going to be another network, but I don't think we're going to make it a subnet of this network right now. And yes, we can, but I wanted to show you a real quick and easy way of doing a visitor network. And we're just going to make this a wireless network. So we've got some visitors here, and I'll just call this visit 1, 2, visit 20. And it's going to use DHCP. So what are we going to use? Well, what we're probably going to do is the simplest to do this, especially in a small office, is to run down to your local Fry's or what have you, and buy another router that has Wi-Fi capabilities. And you've seen them in all your homes and offices. They're the standard Wi-Fi capable router, and they're actually a layer 2, layer 3 device. They do routing and switching and that sort of stuff. So yeah, so the easiest way to do this, just go get you one of those guys, and then we're gonna tie them. We're just gonna tie them right into our main one up here. Like that. And this is for this network. And we're going to actually just give him a whole separate network. And it could be a subnet of it, and we'll look at that here in a little bit. But you could actually just call this 11 and give it a whole class C. It really doesn't matter. Served up through this. This isn't actually a gateway router. We'll just call it the visitor. And then, so what you'll do for layer 3, since we're talking layer 3 today, for layer 3, what you would do in this router here is you would put a access control list, or an ACL, in this router, restricting any traffic coming from these 11 network to talk to anything in this 10 network. So it would be like deny source, destination. So source network, destination network, it would just deny it. And then they'd still be able to have internet access their offices, web pages, and that sort of stuff, but they'll have no interaction with the corporate network. So I went ahead and drew in the lightning bolts. So what are the what's the advantages to doing something like this? Well, the advantages is it could be done very quickly. This is something you could, like I said, run down to Fry's or your local electronics store, pick one of these guys up. Gosh, you can buy them anywhere. I think Target, Walmart, anything, and just pop it in there, pop it into your router, and it has to go on the router. It can't go on the Ethernet switch. It has to go on a router because you're going to do that layer. That ACL is going to be on layer 3, and this is going to have a completely different network. So it's going to be, completely isolated at layer 3 from your physical network. It's physically separated except for where it attaches into the router, and it's easy to manage. You don't have to worry about doing anything else with your network equipment. The disadvantage of it is now you've got two Wi-Fi networks. You got your wireless access point and this visitor router, which doesn't have DNS, by the way, that are both broadcasting wireless signals on top of each other, and that can cause interference and dead spots and can be kind of a mess. Now, if it's sitting out in a visitor area, away from everything, it's probably okay. But if they need to roam your office, and you might run into some problems with interference with the overlapping routers or overlapping Wi-Fi. So some experienced network engineers are probably going to notice that I assigned a whole Class C network to this point-to-point, router-to-router connection. And although that is legal, you can do that, you look like a bit of a dodo if you do something like that. What I wanted was this Class C is for the guests. That way, anything coming from the 11 network, I just have to put in one ACL in this router to block anything coming from the 11 network to be routed to anything on the 10 network. That way it blocks all their access to our internal network, but yet can still get out to the internet. So we need to figure out what to do with this. Now, I can't assign these guys 11 network IP addresses without subnetting this 11 network. And although I could do it, and there's only supposed to be 20 visitors PCs on there, I don't want to do that. So what I'm going to do is I'm going to pick a third network, and this is going to be I'm going to make it the 0 network. Why 0? It's just something that I use for point-to-point networks. Okay, so 192.168.0.1 is going to be this IP address, and this one down here is going to be, I'll just copy this whole thing, and we're going to make him, this is going to be .2. Now I'm also going to change the subnet mask. Now you remember when I was showing you, this right here is the smallest subnet that you usually do, except when you're doing point-to-point, but we're not going to go there right now. We're going to use, I just want 4 IP addresses, and how that's going to work is we're going to have 192.168.0.0, and let me make this a little bigger. And then we're going to have 192.168.0.1, 192.168.0.2, and 192.168.0.3. All right, and this right here, now we always need a wire, so this will be our wire. And we always need a broadcast. This will be our broadcast, and that leaves us with 2 IP addresses. One for the gateway router, the .1, and one for the, this will be the gateway router. This will be the door router interface. Okay, and that's a very typical point-to-point configuration, and I'll show you some more of that later on. So yeah, so then in this router right here, to get to the 11 network, I need to add a route. The route will say basically route 192.168.11 network via the 192.168.0.2 interface. And you don't say the 0.1 because that's local to the router. You always want to put the gateway as the far end. And so what is our subnet mask? It's not 0. So do you remember from when we were talking about, you say you take 256, subtract, there's 256 possible IP addresses in that class C. Subtract 4, and because that's how many we're taking, this is the 4, 1, 2, 3, 4, and that equals 252. So that's our subnet mask. So we're going to come down here and pop in 252, and that tells the routers that this network is now it can calculate the broadcast, the wire, and it knows that this is just a small point-to-point network. So just to clear things up a little bit, so the reason why I couldn't use an IP address from the 11 network for this, like 11.2 and 11.1, is because that would overlap this even if I use 252 here, with this 0 right here, that would overlap this network right here, and the rule of routers is thou shalt not overlap networks. And the same goes with this 10 network up here. I couldn't give it a 10.1 right here and a 10.2 down here, because that would overlap with this 10 with this 0 with this 10 network right here. Since it's using the whole class C, it would have overlapping
That's why I had to add another network.